In this video, we are going to get some practice with the arc and angle relationships that we learned about in other videos. And so let's start with practicing with inscribed angles. In this first problem, we're trying to find the measure of arc AB. Arc AB is this minor arc shown here. And with what's given in the problem, we don't have enough information to find it. But what we are given is we're given this inscribed angle ABC with a measure of 65. And what we've learned is that if an inscribed angle has a certain measure, the arc that it intercepts will have twice that measure. In other words, 65 times 2 would give us the measure of arc AC. Then what we know is I know arc AC and I know arc CB, and we know that all of the arcs together should have a sum of 360 to get us all the way around the circle. And so if you do 360 minus 130 minus 100, it will give you the measure of arc AB, which in this case is 130 degrees. On the second one, we're trying to find the measure of angle EDF, which is this angle right here. We note that it's an inscribed angle, but in this problem, it looks like we're given even less information than the previous problem because we're only given arc FD, which is 140 degrees. Now, what we are given here is some special information about chord DE. This chord right here, because it goes through the center of the circle, you can see the little, how it passes through the center of the circle. That means it's a diameter. So it's cutting our circle in half. So that means this arc right here is actually a semicircle, meaning it goes halfway around the circle, and it's 180 degrees. From there, we know that 180 plus 140 plus the measure of arc EF should be 360. So if I do the math and do 360 minus 140 minus 180, you should get that arc EF has a measure of 40 degrees. If you know that arc EF has a measure of 40 degrees, we see that the angle we're looking for is actually inscribed to arc EF. So the measure of angle EDF that we're looking for is going to be half the measure of the arc. So it's going to be 20 degrees. Let's move on and do some problems with angles created by secant lines. We have a secant line here and a secant line here, and we're going to look about the relationships between these arcs and angles. So the first one says, find V if x is 50 and z is 40. Well, in a previous video, we learned that the measure of the angle created by secants is 1/2 the difference between the outer arc and the inner arc. In other words, this arc minus this arc divided by 2 will give us the measure of that angle. And so let's just fill in what we know. We're given that x is 50 degrees. It's given to us right there in the problem. We still have our 1/2, and then we're not given v, but we're given that z is 40. And so all I can do here is we're just going to use some algebra to solve this question. What I'm going to choose to do, and you don't have to necessarily do it this way, but I'm going to start by multiplying each side by 2, because I would like to get rid of that 1/2. And we have that 100 equals v minus 40. Next step is we're going to add 40 to each side, and we're going to get that 140 equals v. So the measure of this arc in the first problem is 140 degrees. Now, let's do the next one. And on this one, I'm actually going to label everything on our diagram, so I think it'll help us see what we're doing. But it says find x, so that's our unknown. We're trying to figure out this angle. But it gives us that v is 160. Y equals 80. And w equals 70. And so what we've got here is, normally I would just do the same formula as last time. I would do v minus z. I'd multiply by 1/2, and that would give me x. In other words, I'm just going to copy down our formula from the previous problem, because that relationship is always going to be true with a diagram like this. But the problem is we don't know what z is. If we knew what z is, we'd be able to find x. But currently we just have too many variables. So we don't know z, but we know y, and we know v, and we know w. So the only arc in the circle that we don't know is z. But what we know from previous problems is that all of these arcs together should have a sum of 360. So if I do 360 and I subtract 160, I subtract 80, and I subtract 70, that would give me that z here is actually, I'm going to try to write it, is actually 50 degrees. So now I think we can use our little formula, our theorem here. We have 1/2. We know that v is 160, and that we know that we're subtracting z, which we did all that work and found out that it has a measure of 50 degrees. And so if I do that, that means 160 minus 50 would give us 110, and half of 110 is 55. So in our second question, x is 55 degrees. Now, let's do our third problem, and I'm going to erase our little, I'm going to erase what we've labeled everything as. This last one's going to involve us writing an equation. So I'm going to first off label everything that's given. It says write an equation and solve for h if v equals 10h, z equals 3h minus 10, and x is 4h minus 1. Okay? Now, same formula. So we know that x is going to be equal to 1/2 v minus z, but now each of those values are expressed as expressions. So I'm just going to fill in what we know. We're given that x is 4h minus 1, and then we still have our 1/2, and we know that v is 10h, so I'm going to take that 10h and substitute in for v right there. And then here's where we got to be really careful. Our z value is 3h minus 10. But if I write it like that, I'm not subtracting 3h minus 10, I'm only subtracting 3h. So what I need to do is I need to throw parentheses around that 3h minus 10 to show us that we're actually subtracting that entire value. Okay? Now, what I'm going to do now to make this video a little shorter is I'm going to pause the video, work out all the algebra, and then resume the video, because the focus of this video is not algebra, it's geometry. So here we go. Okay, and so I know I skipped over a lot of that algebra, but I've got it copied here and you can now see it. But if you were to kind of follow my algebra steps, and I'll let you kind of look through it, pause the video as needed, but you should end up with h equals 12. If you don't get from here to h equals 12, then your confusion is not with the geometry, your confusion is with the algebra. Now, this is our last slide. We got just a few more practice problems. I think that I got off on my numbering on these problems. Oh well. But we got this diagram. I think this would be a little bit more complicated of an example. But let's start with this first problem. It says find the measure of angle QRS. Well, on this diagram, I got to find QRS first. It looks like we're looking for that angle right there. And so there are a lot of lines on this problem, but what we can recognize is this is the exact same relationship from the last slide. I see that we have a secant line and another secant line. And so we know that to find that angle, we can do the outer arc minus the inner arc divided by 2. So for this particular problem, to find the angle that we want, which I'll just call it angle R, the measure of angle R is going to be equal to this outer arc, which together, this entire arc PT is going to be 85 degrees. You got a 40 and a 45. So that's going to be 85 is that outer arc. The inner arc is 35 degrees. And now we're just going to do some algebra. So the measure of angle QRS is 25 degrees. So I'm going to erase a bunch of my markings on here so this diagram doesn't get too nasty for our future examples, but I'll go ahead and label that this right here is 25 degrees. Now, we want to find the measure of arc PQ right here. Okay, here's arc PQ. We're moving on to the second problem. As I look at PQ, okay, I see that we don't know PQ, but we know this arc, and we know this arc. And if I recognize that this segment right here is a diameter, we know that the three arcs together would add up to 180, because this is a semicircle. The diameter is going to cut it in half, so this is a semicircle. So I do 180, 180 minus 40 minus 35. And that should give us 105 degrees. Next, let's find the measure of angle PTS. PTS is this angle right here. This is what we're looking for. And so what I hope you're recognizing is that this is an inscribed angle. And the inscribed angle has half the measure of its intercepted arc. And so I know that colors are everywhere. Maybe I can erase some stuff and make this look a little better for us. But now for this problem, what we have is this whole angle, or excuse me, this whole arc is the arc to which the angle in question is inscribed. And so I can see that the measure of this arc is 105 plus 35, or in other words, it's 140 degrees. Well, if you know that the arc's 140 degrees, the inscribed angle is going to have half the measure of that arc. So half of 140 is 70. And then our last question is about angle TPS right here. So we're looking for this right here. And so there's probably a few different ways of doing it, but the first way that jumps out at me is that if I look at this arc right here, the angle in question is inscribed to that arc. And so if I can figure out this arc that's highlighted, I could just divide it by 2 and it would give us our angle. Well, while I don't know this arc, I know every other arc in the circle. We have 45, 40, 105, and 35. So I just need to add all those up and subtract from 360, and it's going to give me the arc that we want. If my arithmetic is correct, it's that all of these arcs together, if I added them all up in a calculator, I should get their 225 degrees. So if I take 225 and I subtract it from 360, I get our arc that we're looking for, which is 135 degrees. If I take that 135 and divide it by 2, it's going to give me the angle that we want. If I punch that in the calculator, that angle is going to be 67.5 degrees.